Hey all, I think we are live today. So this is going to be a little bit different than the regular lead code questions because um, it's not just the technical interviews that we have to clear, there's also system design. So I just thought, let's do a system design video. And LLMs, chatbots seem to be a really popular topic in the interviews, in the industry. Everyone is building them, everyone wants you to use them. So it's generally a really good idea to kind of be familiar with it. One thing I'll say is, in my experience, chatbots or LLM based apps are a little bit different than other machine learning system designs because you're not really designing a model, right? So you don't really care about the model metrics, what kind of architecture you're going to use, how you're going to improve the model. Even if you are fine tuning your own models, I think like the modeling part can be abstracted away and it could be discussed later. So, in my opinion, LLM ops generally is a lot more similar to backend design than it is to any of like the machine learning workflows. So that being said, let's go through it. So the first thing in any system design is we need to consider the requirements, right? So what it is that I am trying to do and why. Um, so here we will have functional assignments. So those will be things like, so we'll have functional, we'll have non-functional, right? So functional, again, it's going to be things like, what is the chatbot doing? For this example, let's just assume that it is a let's just assume it's a rag for the company, right? So the idea is that we want this chatbot to search through the documents and search through knowledge base and give answers, basically. So this is like the essence of what we are trying to do, right? Now, the non-functional requirements could be that we need it to be fast, right? And fast is a relative term, but like let's talk about like I'm not thinking of a number right now, but like let's say less than 2 seconds. This is like a very lenient latency requirement. But that being said, like rags generally are slower because you need time for inference as well. The other thing would be to again, like this is like a main requirement, but I'm not sure if I want to put it in the functional or non-functional, and that is like the correctness of suggestions. So it should be based in the ground truth. What that means is there shouldn't be any hallucinations. Hallucinations. Okay. And the other thing could be around scale, right? If it is a enterprise level internal chatbot, then obviously at most you're gonna have like some like of tens of thousands of people, which is sounds like a big number, but it isn't that big. Versus compare it to like let's say ChatGPT, where you'll have millions of users, right? So in any case, the idea is that the number can scale, but what we want is everyone to kind of have like a decent experience. So we need to be careful that our app does not go like it doesn't go kaput, basically. So thousands, and this is ChatGPT. Okay. Um So those are basically the main things. The normally when you're talking about latency, scale, robustness, reliability, availability, all those things are important, and we'll consider them as we kind of like developing the solution. But like these are kind of like the bare bones of our requirements and of our designs. So once we have that, then we'll kind of think about like what metrics do I want to look at, right? And depending on however you are defining the correctness of your system, for accuracy, it could be anything between rogue score, which is comparing the generated text to what a human would have generated given the same amount of information, or blue score. I think in this particular scenario, rogue seems to be a better metric, because we're not really translating things, right? We're trying to retrieve information. So retrieval is a like the summarization overlap seems to be like a good metric to monitor. Um, the other thing would be, again, retrieval, right? So we want to ensure that we are getting the results. Sorry, when I mean retrieval, I mean recall. Um, yeah, so we are getting answers from the knowledge base, right? And especially in a RAG sort of application, you have to be careful when you're deciding on the chunk size and everything, like what kind of vector database you're using, how do you map between the actual knowledge pages versus this. So these kind of things kind of come in play over there. We will obviously be working with latency numbers. So end to end, how much does each API call um, how much does each API call take? Cost of inference. Tokens are not cheap, so having some sort of like LLM routing, or you know, uh, choosing the right LLM for the task, and batching and processing things together using caches to avoid the tokening, these things matter. And like cost could be like the biggest challenge over here. So depending on what the use case is, you might want to optimize for cost over sometimes accuracy as well. So it's like a balancing act. This is the main trade-off. So while I kind of talk about that, the main trade-offs in this case would be, yeah, so main trade-off is obviously going to be between cost versus accuracy, right? The other one is going to be like obviously the latency numbers could be used over here as well. So like latency versus accuracy as well. Cost and latency are kind of in the same thing, right? Because the bigger models are taking like a lot of time to run inferences as well. So like cost and latency are kind of on the same spectrum. They are not against each other in this scenario. That being said, the other one, I think these are like the good amount of trade-offs for now, specifically for like the LLM based RAG. The traditional trade-offs still exist, right? Like when like in the backend system, so things like CAF theorem, things like scalability versus simplicity, so all these things are still part of the play. But that being said, we'll just kind of focus mostly around the specific LLM based things. Okay, so now starting with the design, I have my requirements, I have my metrics, I have my trade-offs, right? So how do you basically build an app? I like to kind of have a diagram that will kind of discuss the flow of the system, and then we'll go in details for each of them. So let's see if I can make a mermaid thing. Amazing. Okay. So the first thing is gonna be like the API gateway. API gateway. I don't know what I did. Mermaid. Okay. There we go. So this will be API gateway. And then actually, you know what? I am going to share the lucid chart instead, or like Excel draw. So let me see if I can go here, and I guess you guys can see it now, the Excel draw. Okay, awesome. Yeah, so I was just talking about we'll have like some sort of API gateway, right? And again, like this is just high level. We'll go in details. So API gateway is gonna be every time a chatbot calls, it will be calling this particular API, and from here on out, we will basically enter the thing. So it's asking for requests, and it is going to get the answer back. And yep, so this is my UI. And once you have it, then this will be the backend. So API gateway, I like having Nginx server for this, just because Nginx server is really good at kind of doing the auth, load balance, reverse proxy, and all of the good things that we really need in like a production app, right? So here you have it. So once you have the API, then you're in the backend system. So the way this works is there is going to be like some sort of inference service, right? This inference service would be, it could either be like a open AI endpoint, or it could be self-hosted, anything. It could be any kind of model. So the idea is you're basically querying against the model. So this endpoint would be provided. And we can, of course, go in more detail if we need to at the end of the talk. But the idea is this sort of service exists. We are building our application around it. And this is what I mean by when I say that ML system design is different than LLM, because in ML, normally you will be the one building the service as well as like the models behind it. Okay, so normally now what we can do is we can, like our API can like directly call inference and pass on the results to UI, right? But that is normally not advised, because the problem becomes when there is a burst of requests, we'll basically overload our inference service. We can run out of tokens. We can get like denial of service attacks. So again, for those things, Nginx is good at handling it. So like rate limiting, handling it, handling DDoS. It's doable um, by the Nginx server, right? But still, that being said, we do need kind of um, like an app, right? So this is my main app of RAG. How it's gonna work is it is going to take the request, um, chunk it, and call inference. Right? However, it will also have access to a cache. What a cache, specifically a Redis-based cache or like a memory buffer cache, can do is it can cut down on the requests sent to the inference service. So some requests are very similar to each other, and instead of having to call OpenAI, let's say, every time, it's much better to call your cache. So you're going to save on the costs quite a bit. The other thing this RAG is going to do is it is going to, so I just want to kind of like make another, the thing, which is going to be a vector database. So this will be a vector DB. And how a RAG generally works is you get a question, correct? The RAG is going to, I mean, it's going to check for cache. If not, then it will go into the vector database, get like the um, relevant doc embeds, and it is going to use those embeds and generate a narrative with it. Right. So at that point, you will have the answers, correct? And those answers could be passed back into the API. Now, this will be like the regular workflow. We'll also need to consider how is the vector database being updated. And for that, normally you will have a database or like a knowledge source. Actually, just for consistency's sake, I'm gonna use all kind of like databasey operations, whether that's VectorDB, a cache, like any kind of data as this thing, and processes are that, okay? So let's just assume it is a knowledge base. What you'll do is you will chunk it, batch it, and vectorize it and save it in a vector database. And a vector database could be, it could be as simple as Faz. Faz is kind of like the standard, I guess, at this point. But Faz is open source, so you have to kind of implement it yourself. Like some of the functionality there is a little bit of the overhead, but it is free. So, you know, again, there's that trade-off. How fast do you want to go? How big do you need the scalable system to be? And do you have the resources to do it yourself? If not, the other option is Pinecone. Pinecone also works very similar to Faz, but it is a, what do you call it? Uh, it's a hosted system, so you don't kind of deal with these things. All right. So now again, the knowledge base could be anything. It could be SQL. It could be PDFs. It could be a like emails. Anything that contains knowledge, right? And there are many ways to kind of like chunk and vectorize and put it in the vector databases, depending on the data that you're dealing with. Now, specifically for PDFs, I believe that you don't actually have to vectorize them because LLMs are really, really good at like just reading PDFs out of the box. So if you're primarily working with PDFs, it's normally better to kind of skip the vectorizing step, but have like some sort of reverse index where you will have access to the particular pages, and then you can query them and get the pages and put them directly in the LLM. But this seems to be like a regular pipeline of the thing. So again, how is data source being updated? Data is not static, right? Um, Data is generated. It could be so data generation processes. Maybe you have emails coming in, docs generated. So what you need to do is you need to kind of keep storing that data and keep chunking and vectorizing it. So like you have to kind of consider about data lineage, right? So things to consider here would be things to consider would be data lineage, how long should it be stored, so persistence. I'm forgetting the word for it, but like persistence policy, I believe, how long the data should live, right? So chunking and vectorizing it. Chunking normally, I believe, like it's better to chunk at semantics, right? So, but like even with semantics, you're kind of hoping to get like 1,000 characters, and maybe like 100, 200 character overlap, because chunking, again, you can't put the entire chunk of data into the LLM. Um, but but you can put a specific chunk of it, but like the LLM needs the context to be stable, and you need like 100, 200 characters of overlap. The other thing would be um, the other thing could be in the RAG, you could also do LLM routing. So what does it mean? You'll have multiple of these services. So these services could be I want to send this to back. Um, yes. Okay. So this would be like whichever service you want to choose. There could be some logic between which LLM you want to use, right? So for complex queries, maybe you want a bigger LLM. Um, but for smaller ones, maybe like a cheaper LLM would work. And normally for RAGs, right, you don't really need like state of the art LLMs unless you're processing PDFs and you don't want to push the vectors into it. You want to push the entire um, PDF. In that case, having a stronger LLM would work. And I guess that is pretty much like the big design of it, right? What I will say here is you do need a queue. And I'm not sure if Nginx server supports queues right off the bat. Um, if not, then if it does, then we'll just enable it. But if not, then we should kind of like have a queue over here. Right, so this should sit between our app and our APIs. Rate limiting is getting taken care of. So what would happen here is like the queue would basically keep track of all the incoming requests and our system will process them one by one. Because like at the end of the day, we don't really want to overwhelm our application, right? So things like first come first serve work really well, and once it's combined with rate limiting, we are sure that a person just isn't bombarding us with their requests. And again, it prevents with denial of services attacks as well. One more thing that I would like to notice is like we need a database, like maybe DynamoDB or Postgres or like some other NoSQL database to basically keep track of um, like things like session storage, things like memory. And again, this is a little bit like a cache, but a cache could also be specifically used for vector database, right? Like for example, if I am getting requests on a particular process, let's say returns of products, there's a policy documented, and if everyone is querying it all the time, like I don't really want to like query my vector db all the time, right? So I could have a cache there. And then I could have like another DynamoDB slash, persistent storage kind of like cache slash database that would keep track of user interactions. Um, so user session management, things like that. What were they talking about? What were they not talking about? And for this as well, there could be something in the middle here, right? So what could this mean is, yes. So what would this mean is, again, we are keeping something in memory, right? And we'll batch it, batch updates to our DB. Batch updates 2 dB, because this way we'll save up on our resources, right? So not everything is synchronous. This kind of like runs periodically. And the cache combined with the actual database would ensure that the system is persisted. Now, I know like this is not fully comprehensive system design of an RAG application, but this seems to be kind of like the framework over here. And I'm just gonna like clean it up a little bit so it is easier to understand. So I have my UI here. This is where my requests are getting from. I have my API gateway server. So this will take care of auth, load balance, reverse proxy, DDoS attacks, as well as rate limiting. Right? Then you have your RAG application. And again, there could be multiple inference services. And then you also have a RAG. You have a queue. Queue is for the incoming requests. This kind of like LLM routing. Goes up there. You will have a database that will take care of things. You'll have a cache in the middle, right? Now, once you kind of have results over here as well, what you want is a monitoring service. So a monitoring service would be, let's just say it's monitoring service. So what the monitoring system is going to be doing, it is going to be looking at things that we discussed earlier. Latency is one. So we could use any sort of like Prometheus for this, open telemetry. We can have regex to kind of like look at the results that we are getting from our API versus from our so this will be my results kind of coming in, and then the monitoring tool will just like it depends what it could be, right? It could be like a live analytics system. It could save results and like basically run SQL queries based on the results that we are seeing from the database. Or it could just be like something like Datadog that actively monitors the API. So the kind of service and everything that we are showing in the monitoring dashboard, that would differ. But in general, we want something like that to exist over here. And again, this particular data generation would go here too. There we go. So this is my data source of truth. I'll have my vector DB. And I'll kind of have like a cache that sits in the middle. So I'm gonna make it green, yellow. So this is again data thing, just kind of giving them similar colors. Fast is again like a sort of database. This cache would be here. So we'll only hit the actual database if the cache misses. I'm trying to move it. It's not moving. Okay, anyway. And this seems to me that this is like a very, very simple RAG solution. So kind of going back to my Notion page again. We'll go to here and see what else did I miss. We discussed trade-offs. We'll, depending on how you, kind of like talking more about like the trade-offs, right? I'm gonna remove this. So what can I do to ensure that I'm getting what I'm getting? So for example, for cost, like my options are I could batch the incoming requests and make call to LLM. The other thing is obviously context monitoring is super important, and that is for accuracy. Context monitoring, and that is what we were talking about when we were talking about DynamoDB, or like or like a Redis-based memory, so we know what each of my user was talking about, right? So we want there to be persistence. Then we also talked about caching the actual results, and the requests as well, right? So if many people are talking about the same thing over and over, for example, the returns, what we'll need is we can have that return in our cache, and instead of hitting our like vector storage and everything, we can just like persist it and keep reusing the same thing over and over again. And then here, this is what I mean by vector DB part. And then of course we can also save the results, right? So if everyone is asking me how do I how many days do I have to make a return, right? The first time we got the request from LLM generated a narrative around it, and it gave like, oh, from the beginning of the return you have 30 days to do it, like this is blah blah blah, right? Like whatever they write. We can also cache that, the actual LLM result, correct? So yeah, so the caching would help with cost. Context monitoring would help with accuracy / user experience. LLM routing could be in both of these. Because again, it's going to save with cost. At the same time, it's going to improve accuracy where it really does matter. And for accuracy, like decisions around chunk sizes would matter, like chunking decisions would matter, how many chunks you have, what is kind of like the overlap between two chunks that are next to next, um, and basically things like that, right? Then, mm, yeah, yeah, and I do think like that is pretty much it. Oh, I just realized that you guys did not get to see um my Notion page when I was writing. So I hope you can see it right now. And it is there. Awesome. Awesome. Okay. Yeah. So this is mostly what you'll want your system design to be like. This is not like this is not a pipeline design, I would say. This is more of a um application design. However, there are different scenarios that you can do. So, for example, like this thing, this is an app design. For the next time, there are many things that we could do, right? Like we can talk about inference service design. How are you managing multiple endpoints, things like that, like specifically going more into details on LLM routing, how exactly the decisions is made. Normally you can use like LangChain or something for this, LangChain or LangGraph or things like that. The other thing that we could go more in detail is the data pipelines, right? How often do you refresh? Um, how do you ensure consistency, right? And when consistency happen, how often do you reindex? So again, like cat theorem again, um, that will be like a big challenge. um, it is a big challenge already in production, but again, kind of depends on which angle you're looking at. Like right now the system design is from an app design perspective. You're designing a chatbot, you have support with infrastructure, you have support with like the data pipelining and everything, like there's a feature store available. But if you're the one who is creating the feature store, then that is like other side of the coin. And I hope I'll basically go back and recreate like in one of the next calls, I'll try to like create a system design from that perspective as well. But yeah, for now, this is it. Thank you so much for watching. Bye.